This is lesson 28 on complex fractions in the denominator and radicals in the denominator. We want neither, so we're going to eliminate them. And the way you do that is, let's look at 28.1. It's a over b in the numerator over x plus y over b in the denominator. So when you have a fraction in your denominator, we want it to eliminate it, and we do that by multiplying by its inverse. So its inverse or reciprocal is b over x plus y, and we must multiply by b over x plus y in the numerator and denominator, because that is effectively just multiplying this fraction by 1 and doesn't change its value. Because we're multiplying, our denominator, fractional denominator, eliminates. And in our numerator, because we're multiplying, we can reduce numerator to denominator, numerator to denominator. Our b's eliminate. Our simplified answer is a over x plus y. Okay, so you're going to multiply by the reciprocal, eliminate your fractional denominator, see if you can reduce in your numerator, and then give me your most simplified answer. Let's look at, from this lesson, number 18. Number 18 reads x over m plus p, all that over y over m plus p. Again, we're going to eliminate our fraction and our denominator by multiplying by the reciprocal of the fraction that's in the denominator. Our denominators completely eliminate because we're multiplying. Oops, I did that wrong in the numerator, didn't I? That should be m plus p over y. Because we're multiplying, we can eliminate our m plus p only because it is the exact same term, and only because we're multiplying. My simplified answer is x over y. That is what I am left with. The second part of the lesson is eliminating radicals. When you have a radical in the denominator, like example problem 28.4, has 2 over 3 times the square root of 12. To eliminate a radical, you simply multiply by that radical over itself. So we'll multiply by the square root of 12 over the square root of 12. 2 times the square root of 12 is 2 times the square root of 12. 3 times, this is effectively a 1, so that's over 3. And now we'll multiply our radicals. The square root of 12 times the square root of 12 is simply 12. So it's 3 times 12. Because, again, these are multiplied, I can reduce. I can't reduce my radical, but I can reduce my 2 and my 12 by 2. 2 goes into 2 one time. 2 goes into 12, 6. So I'm left with the square root of 12 over 3 times 6, which is 18. And I now have no radical in the denominator. Let's look at problem 19 from this lesson. Number 19 is 3 over 4 times the square root of 15. Again, to eliminate my radical, I'm going to multiply by it over itself. The square root of 15 over the square root of 15. 3 times the square root of 15 is 3 times the square root of 15 over 4 times, again, square root of 15 times the square root of 15 is 15. So the very same radical multiplied by itself is always just the number under the radical. So it's 4 times 15. Because these are multiplied, I can see if I can reduce before I then multiply it out. 3 and 15 can be reduced. 3 goes into 3 one time. 3 goes into 15 5 times. And I'm left with the square root of 15 over 4 times 5, which is 20. And that is my most simplified answer.